All right, so this goes along with lesson 22, measuring volume. And it talks a little bit about Archimedes and what he discovered when he sat in his bathtub. Now, if you watched the video for the warm-up, you'll know that when Archimedes sat in his bathtub, what happened to the water level? Yeah, when he sat in his bathtub, the water level went up. See, whenever something is put in water, that object pushes the water out of the way. The fancy way of saying that is all of this water is getting displaced. It's getting pushed out of the way. So when Archimedes noticed was, this is a bit of a mess. The amount of water that got displaced was equal to the volume of whatever got put inside of it. The volume of whatever object went into the water was equal to how much water was displaced. Now, I'm going to pause for just 1 second as I clean this mess up so Ms. Smith doesn't kill me. Okay, so now that I've gotten most of that water cleaned up, it looks like if I want to measure this, I'm going to have to be a little bit more careful. So I've come up with a new plan. So I have a bunch of other stuff here. Like I have a large bowl, and that large bowl is here to catch whatever water comes out so I don't have a giant mess. And again, I'm going to put a little something in that large bowl to hold up my small bowl. And my small bowl is going to be like Archimedes' bath. It's going to be filled with the water that I'm going to measure. And of course, a measuring cup. So here's what we're going to do. In order to measure the volume of something, I'm going to fill the inside bowl all the way to the top. I'm not going to let it go over, but I'm going to make sure it's all the way to the top. That way, the minute I put something in, it will displace water, and that water will come out and fill up the larger one. And if I do this right, we can find the exact volume of some pretty common objects. So, as a reminder, volume is how big something is. This method doesn't measure mass. You're going to have to get you a scale for that. This is just measuring how big or small the object is. All right. Let's start with a simple object. My hand. I tried that earlier. I want to measure the volume of my hand up to my wrist. Now, if you want to do something like this at home, you can have a setup just like this, and you can measure the volume of your hand. Your hand might be different than mine. So what I'm going to do is I'm going to put my hand in the water, and I'm going to let it displace whatever water it displaces. Just put the water all the way up to my wrist. You'll notice that it pushed some of the water out. The water down here got displaced and should be the exact same volume as my hand. Now, before I continue, the next step might be to dry my hand off so that I can do all of this. Now what we want to do is we want to measure how much water got displaced. So I'm going to carefully take out the bath water. I'm going to set that aside to use later. And I'm going to take out this little stand. It was just there to hold my bath water up. And now this is what I've got. So I want to know how much water that actually is. I'm going to carefully put it into my measuring cup. And I'm going to find out what the volume of my hand is. So I'm using a measuring cup right now. So my measuring cup measures in like cups and half cups and quarter cups. If I needed a recipe that called for 1 human hand, my hand is 1.5 cups of human hand. The volume of my hand is 1.5 cups.
How's that for Halloween recipe?
All right. Well, I think it's kind of cool to know what the volume of my hand is. Let's look at a couple other objects, like this little bitty candle, lovely little scented candle. I wonder what its volume is. I mean, it's kind of a weird shape, so can't really measure with a ruler. So I'm going to start this all over again. Got my setup here. I'm going to put my Archimedes bath water up top. I'm going to fill it all the way to the top of the bowl, but not over, just to the top.
And now it's time to displace. Remember, as soon as I put this in, the water is going to come pouring out. So once I've done that, I'm going to want to take my candle out, set it off to the side. Can still use it later once it dries. Going to remove my Archimedes bath and remove the little stand. And now, for an even closer measurement, I'm going to put it back in the measuring cup because I'm curious. How big is this candle? What's its volume? Turns out the candle's not quite as big as my hand is. I guess that's not a surprise, but it's a little bit closer than I thought. The candle's volume is 1 cup. So 1 cup, same volume as this candle. Oh, now I want to do more things, like this rock from my rock collection. It's a lovely little crystal geode, a little bit different from the one I showed off earlier. I got to be careful because all my stuff is glass. So I'm going to lower this in there very carefully. I can already see some things displacing. And now I got to be really careful. I'm just going to take the Archimedes bath out with the rock in it. And then I'm going to measure whatever water got displaced. That was kind of surprising. I feel like the rock looked bigger, but it's only about a half cup. And I'm wondering why. And when I look at it, I realize that even though it looks like it's the same size as the candle, the inside is hollow. So it's a little bit of a different shape. And because the inside of it's empty, it doesn't take up as much space as that candle does. Now, the real question, are these really careful measurements? I would say no. I would say these are not super careful measurements. In order to get a careful measurement, I've got to change my tools a little bit. This is a graduated cylinder. This is a really careful way to measure the volume of a liquid. It's a lot more careful than my big old clunky measuring cup. If you look closely at a graduated cylinder, it marks off very small volumes, so you can measure really, really closely. Here's a close-up view of the graduated cylinder. You can see along the side here that it marks everything in what we call milliliters, and those are really, really small. For comparison's sake, this is the pen I'm using to write down my notes today, so you can see how small milliliters actually are. Now, in order to use Archimedes' principle, I'm going to be really careful, and I'm going to get mine right up to 50. A little bit more. So right now I see that my water level is right at 50 milliliters. Now, if I was to drop an object in here, what would happen to that water level? Well, obviously it would go up. This is a great way to measure smaller things, especially things that can fit inside this cylinder. Things like this metal marble, for instance. This metal marble would fit inside the tube. And if I was careful enough and I dropped it into the water, I might notice the water level rose a little bit. It started at 50. Let's take a look at what it's at right now. Ew. So I'm seeing it started at 50 and it went up to about 58, maybe like a little past 58. So if it started at 50 and it went up to 58, how much is that? This metal marble has a volume of 8 milliliters. When we dropped it in, the water level went up 8 milliliters. So that's how big this thing is. The volume of water that got displaced is the same as the volume of this object. How about something even tinier? I'm going to use an even smaller set. I'm going to use a smaller graduated cylinder and a smaller marble, and we can measure an even closer amount. But we do it the same way. All right, my little baby graduated cylinder is filled up to 20 milliliters. Each one of these marks is, I believe, 1 milliliter. Ooh, no, each one of these marks is half a milliliter. So it measures really, really, really carefully. I'm gonna put a drop or two in here to make sure that it's right at 20. That should be good. And now I'm gonna drop in my little metal marble and see what happens. Now you might notice that it didn't change a whole lot. This marble is pretty small. And if you wipe this off so it's easier to see, you might see that this marble got to, well, I don't know. What do you think? Yeah, I would say it's probably somewhere between 20.5 and maybe close to 21. So let's say 21. So if we started at 20, we put the marble in and it went up to 21. What's the volume of the marble? 1 milliliter. That's a pretty precise measurement, especially compared to how we were doing it a little bit earlier. This is a great method when you're measuring certain things, but it doesn't always work. Let's be real. There's a few things that this might not work for. I mean, let's be honest. There are certain things you just don't want to stick in water. You know, I'm not going to use water displacement to figure out the volume of my phone. That would be a bad idea. And some objects, even if you are willing to get them wet, and they'll be fine if they get wet, well, they don't really go underwater. So that could be a problem too. So the water displacement method isn't always the ideal. So there you have it. If you've been following along and doing your job, you've been able to complete the lesson 22 measuring volume activity while we do this. If you need to go back and watch some of these things again, feel free to do so. Also, I'm curious, what are some things in your house that you could use water displacement to measure? Let us know if you find something cool. If you find the volume of something interesting, that would be nice to know. I'm wondering what the volume of like your whole body would be. That would take more than just a bowl in the kitchen, but that would be something cool to do on your own. Anyways, thanks for watching.